Hey, welcome back. Time for another episode of MassTransit Season 3. Durable Futures is the topic. And yesterday, even Friday night after the happy hour episode, yesterday was kind of an all-day coding binge trying to get this thing figured out. There's definitely a lot of pain exposed in Friday night's episode. We had a lot of duplication, a lot of cut and paste. It was a frustrating effort, but I really had to kind of tease it out and just see how bad it was. And fortunately, after yesterday's work, we have a lot better position today. Everything's a lot cleaner. It isn't perfect yet. There's definitely some questions I have about the way it's set up. But I think we're getting a lot closer. So I'm pretty excited about it. I think it's going to be kind of fun. So hopefully, if you've watched the earlier episodes and you've seen I don't know, for lack of a better word, some of the painful bits that are in there, you're going to see a lot better content today. So I'm going to try to keep today brief, but I'm definitely going to go into the details. All right, so let's get started. We have some number of changes to the solution. I want to point a couple things out first once you pull down the code for this and once I get it on GitHub. I created a separate fork joint components project. And the reason I did this is because I wanted to put all of the future basics into that project. I wanted to avoid circular dependencies. I wanted to keep a clean layer of what am I adding on top of MassTransit versus what is my actual project code and how I'm using that. So you'll notice that in the solution. You'll also notice that there are actually tests in the test solution now. So funny how when you actually start writing code and trying to prove that it works, unit tests are really valuable. So I'd kind of ignored those most of the season, but those are alive and well, and now I'm able to test those. So I want to start off with kind of the tests and how I set this up. So if you remember from the previous episode, we were creating a state machine for every single future that we had. Never going to work. I mean, that's just, it was like 6 files per future that we had to create. No way that was sustainable. So from a decision perspective, I did decide to use a single state machine with a single state table. And that's something to be aware of. And I'm still looking for feedback on it, but the initial feedback I got is you can fix this with back-end database solutions. You know, right now we're using Entity Framework Core, but there's no reason you have to. You could shard it across Mongo. You could use Cosmos. I mean, you could really use anything that would probably scale better than a relational database on a single table. Plus, I think you can even just use shard sets within SQL Server. So there are a number of options to scale the storage. But I stuck with a single Saga repository because I wanted to kind of give myself, I don't want to define maps every time. I want to have just some baseline out of the bunks functionality that we can use. So yeah, but the interesting thing is, while it's still a state machine, a lot of that machinery under the covers is sort of obscured. And it isn't obscured, it's fully accessible, but it's taken out of the way through a series of classes. So let's start with a very simple consumer-based one. Let's look at our Fry future and see what it looks like right now. Night and day difference. I mean, it's drastically reduced the amount of code to create a future now. I mean, a Fry future, this is a request future. It sends a request. Remember, we broke request response apart to command and directed event. So it has an incoming request type, order Fry. It has a response type, Fry completed. And then it has the actual service types, cook Fry and Fry ready. And that's what the ultimate consumer that handles this request does. And I just have to overload 2 methods. One is to create the command, which I'm toying with the names here, but essentially I'm just using the message initializer to create the cook Fry command, and it has the order ID, order line ID, and size. Now the interesting thing about this is I could take out every single one of those statements, because what this initializer does is it takes what we know about what's available and applies it to this message type. But I'll go into that more. Actually, this one won't do that. Never mind. Sorry, my bad. But this will create the command. And I pass it the 3 things it needs: the order line ID, the order ID, the order line ID, and the size of the fries to cook. And that's it. If we go back and then once that request completes, it calls this create completed to say, okay, well, this is completed. I've received all the response and everything. I want you to take that fry ready and produce a fry completed. And that's where we use this other init method, which right now all we're passing is the description. And I'll go into that as we kind of dig into the base of this. But I like what I'm seeing so far. It's a lot cleaner. Hopefully, I mean, significantly cleaner. No cut and paste. It's just very, very simple methods. I do have to specify the initiating event because I need the correlation ID. And in this case, I'm using order line ID, which is part of the order fry command or order fry request that came in. So let's look at the request future and kind of dig down. Now you're going to see a lot more code in here because this is where the actual nuts of the nuts and bolts of the request future are located. You also notice I've eliminated all the state machine terminology and all that. It's just, this is the future. Let's just stick with it as that. So the request future has two events that it knows how to configure automatically. First of all, it's going to correlate by the incoming request ID. So when the response is sent from the request, it's going to look for that request ID property. And if it isn't found, it's going to throw an exception. If it is missing, we are forcing a fault because that could actually trigger a retry. If our consumer responds so quickly that we haven't even persisted this instance to the database yet, some optimistic stores might just discard it saying it didn't match. So we want a fault so that our retry handler will pick up if the event isn't there because we know we're going to be there. We sent the request. So I correlate both the fault and the response, which the response in this case was fry ready. Then I handle in the initially where I actually create and send the command. I'm not sure I like this entirely yet, but it's so buried from you, it doesn't really matter. It makes it fairly discoverable. But we put the response pipe together, which just sets the response address and request ID. And then we send the command to the actual requester. Now, right now, originally we were just doing publish, but I added a destination address. So if you configure the destination address on your future, you're able to use that and it'll say, okay, well, I'm going to send it directly to that service address instead of that. So when you create your future, if you want to pass in some settings and use something other than the default publish for the request, you can certainly do that now. So that's possible. The create completed, as you can see, is by default pretty simple. It just calls init with the two incoming things. And I'll go into that init shortly. The create fault, you'll notice that all the faulted events are gone. You know, the order line faulted, all of that just didn't really make sense. We have fault built into request response. So I figured we'll just continue to use that message type. It doesn't require an exception to be thrown, but we can treat it just as such since fault's kind of a de facto negative result for a request. So the create faulted, all it does is initialize a fault based on the response type. So it will actually translate the incoming fault to the outgoing fault. And you can see when we have the message types here, there's 4 different types in the request response. There's the request and the completed for the future, and then there's the command and the result for the ultimate consumer that's going to handle the request. This is kind of like a man in the middle kind of thing, is we're actually acting as a proxy to the consumer by being a durable future. And in a way, it isn't unlike a request cache in that once we've saved the value for that request, we have it available so we don't have to ask for it again. So that's going to be a subsequent episode. I'm not going to dig into that much, but the capabilities around being able to cache requests and generate identifiers and stuff are pretty creative. I have a long feature document on caching requests via this gateway pattern to make it so that we can reduce load on backing services by keeping information around. And that actually was one of the impetuses that spawned this whole idea of durable futures, because a cache management is just kind of a pain. And by able to complete things and keep them around, we have some different possibilities. So future episodes as we build this out, but so far it's looking good. So this is the request future. When the command completes, we set the future to completed, we notify our subscribers, and we transition to completed. The use of the whole separate request state machine is completely gone. Every single future keeps track of all of its subscribers now, so it doesn't have to do anything special. Any subsequent requests that come in while the future is still waiting for completion are just saved on the future. So I did make that change to eliminate the message communications with the request state machine and also just eliminate the dependency on it. When the fault comes in, we set the future to faulted, we notify the subscribers, and we transition to faulted. And this is simple with the request because it's a one-to-one. We get one in and we send one out, and we expect one response, and as many people ask for the same future, we're always going to have that same response. So there isn't need to like aggregate responses or do a join at this point. So it's working pretty well. You can see the events. The event of T result is the result, or the event of fault T command, or the fault. So great, perfectly set up, very symmetrical. The send command, create completed. This init method is something that I'll dig into. It is using the message initializers, which work with classes, records, interfaces, everything. So there isn't really a reason not to use them. But the benefit we get by using them is we will pre-initialize all the properties of the message type using the data that's actually in the message that came in. So for instance, if we get a response like fry ready, we can copy any properties that match the names and types of our completed message automatically. So we're auto mapping these back out, not auto mapper mapping them. Jimmy keeps coming up, but you know what I mean. But the initializer will copy those values over from the T result. It will also copy any values from the future into that result, such as canceled, completed, created, deadline. These are all dates and times. And it also now adds the location, which is interesting, and I'll cover that shortly. It then gets the initial request that's stored with the future. And if that's there, it will copy those properties over. So there's probably an ordering thing. I should probably do that before I copy the new stuff. But yeah, I don't like that. I think this is going to go the other way. This needs to be this way. I need to initialize it initially with the request. I'll do that later, though. And then any values that you ultimately pass in will also be initialized on that. So if I pass some overrides, like I'm setting the description in the fries, that will get added as well. And once all that's done, I return the message. There's still a to-do here on the headers, to-do on headers, but I'll get to that. Okay, so the default future with just two types just handles the fault of the request, and that's kind of an interesting case, just kind of a middle one there, so that it doesn't really freak things out. But anyway, great. So that future sits on top of a MassTransit state machine. Great, perfect. Everything's wonderful there. Cool. So that's the core future. The request future has the request stuff in it. The init is in the core future. And then all of the response stuff is handled in that. So if we go back to the fry future, very, very simple setup. If I go to the specs for the fry future, you can see I have a setup with an order line ID when it started. I create a scope. I get the request client. I call get response on fry completed to send the command to do that. I order some medium fries, and then I verify that everything came back. Obviously, this is showing as green, so it ran. Everything's cool. And it gives us the ability to test that. The dependencies that I add in here are kind of interesting. And remember, we're building this outside of MassTransit, so I don't have a way to register these automatically through configure endpoints yet, but we're getting there. So, you know, that's something that will come once we get around to making this a first-class citizen. But the dependencies for a French fry maker are pretty simple. I need a fryer. I need the cooked fry consumer. I need the request client to order the fry. And then as I'm configuring the bus, I need to add a future endpoint. And this is just a shortcut that I've made to register a future on an endpoint. If you remember the previous code, and I've trimmed it down a little bit, but it's pretty good. This is pretty simple. I'm just naming futures based on the name of the future. So I'm using the message. I'm really hacking this to use the endpoint name formatter of the message, which really just takes the class and gets a name. And I'm using that to get the name for the endpoint. So what this ends up being is like fry-future. And then I apply the future endpoint configuration, which sets scheduled redelivery, message retry. These are just conventions that I've put on here. Hey, what's up? Welcome. And then I do the retry in the in-memory outbox because I want, you know, these are state machines. I want to have stuff that I would typically put on a state machine on there. I'm going to get the partitioning figured out because I want it to be pretty awesome. But the piece with the partitioning I've got to get now is I want to be able to interrogate the state machine for the events and get their correlation types and automatically apply the partitioner for the events coming into the state machine. So that'll happen. It's just I didn't want to clutter this up with that right now. And it isn't really necessary for the unit test. So what we end up with is we're manually configuring the endpoint for future endpoint. And if we look at like a super complex state machine like the order future state machine, I'm just configuring all of these future endpoints for the burger future, fry future, shake future, FryShake future, onion rings, order. All of those are just getting configured, and those are going to create separate endpoints. So that's really kind of, we're able to actually unit test an entire order now within the unit tests. And if I have to actually kick this off, you can see it looks a lot like our Postman script. I'm setting up an order with some fries and a burgers, no shakes, no FryShakes, and I'm asserting that it completed. And so when I run this, if I just run this, I have two different ones. I have one that runs it once and then one that runs it twice to verify that it does complete through the durable future and like immediately completes versus running twice. And we can see that all these are going to run and succeed. So that'll give you a way to just kind of walk through the unit test without having to fire up Postman and submit requests through the controller, although you can still do that. It even checks faults, which I actually found a very weird race condition by testing subsequent faults within the same process, because what was happening is because the burger faulted, because of the lettuce, it put the burger back on the grill, and then the next time it ran super fast, and it actually ran into a timing issue. So unit tests are good. They definitely do things that us as humans aren't going to be able to do by the keyboard. So these are all in here now, and they're certainly helpful to kind of explore what's in there. And if we go in and look, I don't have App Insights turned on for unit tests. Yeah, no fork tree there, but you can see that all of these are the Saga future state. They're all going in there. So like created, added, created, added, created, added. I almost want to mute these because I feel like they're going to be noisy, but they actually have been pretty helpful for figuring out. And you can see the messages like order burger, order fries. So the messages at least give a little bit of discrimination on what type of future is being handled on that future state. But it is definitely going to that Saga repository. And if you notice from the future endpoint, which is here, we are actually using a single Saga repository for this. So you'll notice when I say Saga state machine with provider, it's going to pull the Saga repository out of the, and I'm hard coding this. I'm not using configure state machine, so don't get crazy on that. Again, once we get this integrated, you'll just be able to do add future in the add MassTransit, and it will add it and set everything up for you. But when I go into the base of this test fixture, you can see that I'm only adding one state machine. I'm adding a Saga repository for future state. That's the only Saga repository I'm adding to the container because that's the only one I need, and I'm using that for every single future endpoint. So they're all running on separate endpoints, so you get a nice distributed queue spread, but they all do then go to the same single Saga repository. So just for some clarity on that. Okay. So that was like the whole order running as a unit test, and we were able to see that. And if we go look at so we looked at the request future with the fry future. Let's look at the burger future, because that one uses a routing slip. And so far, we kept the concept of the itinerary builder with the future. And I'll show you how this comes together. So with the burger future, again, future requested, we set the event based on the burger ID. We could just as well do it by the order line ID. In fact, we should, but I didn't clean that up yet. And then we create the completed event, which gets the burger from the routing slip variable, and then calls the init from routing slip completed to burger completed and passes the burger in the description. So we meet our previous contract that we had before. But what does a routing slip future do? Because we looked at the request one, and that just sends the request and waits for the response. The routing slip future is a little bit different. This one actually correlates back by tracking number, which I recognize is going to have to change because in the next or one episode after, we're actually going to add retry and fault handling so that we can have fault tolerant durable futures that will retry in the event of failure, so that we can actually resolve the issues before completing the future, completely opaque from the application that wanted the future. And again, it just gives us that layered composability of all the different capabilities of MassTransit underneath the covers here. So when we add fault-tolerant retry on this, it's going to be very similar to the stuff that I added for the job consumers, where we're tracking the executions and then tying them back. So it should be pretty cool. But that's more to come. For now, we're just doing it off the tracking number. We're going to assume that it's going to succeed or fail and that future will complete. And you'll notice when the future comes in, we actually use the execute routing slip future activity, which this is just one activity. You don't have to create this for each routing slip that you want to initiate, because all you have to create is the itinerary planner for that future. So you do have to create an itinerary planner for that, and that's the type that is matched to the order burger input. And I think that that's going to be enough to identify it. We'll see how it goes through then. But this is still doing the same thing it did before. It adds our variables to the routing slip. It gets the burger. It adds the activities. It's still, so I moved the pre-ordering of the onion ring to the itinerary planner. And we're still creating that future with the address ID by calling publish. And then we're passing that onion ring ID now to the actual dress activity to tell it so that it can then go out and use the request client to ask for that onion ring. So that's kind of a nice little tweak. So we're still able to keep that functionality separated out within the planner. Once the routing slip is planned and we have the two activities on it, it just executes it, and that's it. Then it just kind of sort of goes to sleep until the routing slip completed or routing slip faulted events come in. Once those two events come in, it's a lot like the request future. You can call init on the completed context and it just finishes off the event for completed, which is great because it just copies everything from the input to the output. Or we can create the faulted, which creates an actual fault of T. So we're translating the routing slip faulted to a consistent fault of T message that includes all the details that came from the routing slip faulted event. So it's just sort of a loose copy to get the activity exceptions into exceptions, but gets it there and it gets the information we need. So that's pretty cool. And then it notifies the subscribers. It keeps track of that. The third type of activity that we have in here, and again, all of these are in the components activities folder, or I'm sorry, the components futures folder. Onion ring future is very much like the fry future, very similar. Shake future, again, very similar, just has some different properties on it. Another interesting one that we had was, so let's look at the order future. So the order future, I chose to stick with the activities that I had in place, but I moved some of the functionality for adding to like the pending list and such. And so I'll dig through that a little bit. I actually was able to tease this out into an intermediate class called order line future, and I'll go into that in a second, but let's look at the order future. So the order future, when the order is requested, I have 4 different activity types: burgers, fries, shakes, and FryShakes, because let's not forget, we created that hybrid kind of bundled item. And all these do now is, if there's burgers on the list, we will publish all the burger requests, we will add all the burger IDs to the pending list, which is stored within the future state, and then we go to the next activity. Pretty simple. All of these are the same. So like order fries, it's like, hey, if you want some fries with that, we'll put the fries in there. We'll get the input address. This might clean up to where we have a base activity. I don't know. I don't know that this needs to, we'll figure out where that goes. Technically, I could probably put this in line, but I did it with activities to kind of keep it separated out. Since this doesn't have any dependencies, it really doesn't need to be a separate activity. I could just do it in line, so that's another option as well. And I might make some cool extension methods that you can use in here to say .fan out or something. I don't know. It's, I'm open for ideas there. The FryShakes activity, again, it sends up the order FryShake, and we'll look at that one next. But the order line future, it has 3 different types: submit order, order completed, and order faulted. And this is using the 3 generic argument version where I'm actually saying I don't want to return the default return type of fault submit order. I actually want to return order faulted that has more information. And that's where I'm copying like the faulted lines, completed lines, exceptions in here. Because I don't want to just use fault of T. I want to have a different fault type. So that's why I have this version in here. So let's look at the order line future. Order line future is a little more involved, but again, state machines make building this stuff so easy. It's just like, it's pretty cool. I mean, the capabilities that are in there, I like, and that's not just me talking about it. All of these messages correlate by order ID. And what we'll see is that all of the different completed messages that can come in all implement order line. So order line says, okay, an order line has an order ID and an order line ID. And this, again, this is in my business side. This isn't a future thing. This is how I'm using futures within the fork join API. And so all of my order commands have that interface order line. And I actually want to exclude from topology because I don't want that created on the broker. So I'm going to throw that in there while I'm sitting there. I don't want to see that in RabbitMQ. I don't want to, because I'm never going to consume order line. I'm not going to publish that and accept to consume that. So I don't want it on the broker. I don't want that interface type showing up out there. But then when I go to like order burger, it just has the burger. Or when I go to order fry, it just has the size of the fry. So all of those are fairly unionized around that interface. And that way, if any of those fault, I can consume the fault of order line, and because faults are polymorphic on the generic type, I can actually consume the fault of the base type, and MassTransit will dispatch that event to me. So any of those events that come back as fault, I'm able to process them, get that general information off them, and mark them as completed or faulted. So super clean way to just kind of make your commands do that. And again, that top level command is that, I don't know how to say it other more than that. It's that abstraction layer to those message types that you're sending as commands from a future. So while things are running, if a line is completed, it's going to set the result. So it saves every message that comes back. And that's useful because then we can use that when we finally complete this multi-child kind of order line future with that information. So we're saving those lines. If at that point we determine we've completed, meaning all the pending lines have completed and the completed timestamp is sent, then we will actually set the future completed using our create completed method, which in the case of the order creates this order completed message with the lines completed because we saved all those lines, so it reports that back. Then it calls get completed because it wants to use that message we just saved and then notify all the subscribers about it. All that does is go out to the results and try to get the result for the correlation ID of this event. And it then transitions to completed. If, however, we have not completed yet, then we check to see if we're faulted, because if we had previously received a fault and then we now completed like the last pending item successfully, aka this was previously a race condition, we want to complete the overall, we want to still fault the routing. We still want to fault the future because one of the pending items faulted. So in this case, we will actually then, just like we do down here, set it to faulted, notify the subscribers of the faulted event, and transition to that faulted state. In the meantime, if the last response we receive is a line faulted, we call set fault, set result or set fault with that order line ID. And then we set that value. I don't think I have to do the task set result there yet. But anyway, it doesn't matter. It's just a mapping. I think it's because it uses an async message factory. All the built-in state machine types are still used. So there's compatibility with those. And now if we see that when we receive a line faulted, we know we're going to be faulted. So the only way the faulted timestamp is set is once all of the pending lines have completed. So at that point, we'll set it to faulted, we'll set our future faulted value, we'll notify our subscribers and complete out. So that's that base order line future. And I'm able to use that same order line future in the FryShake. It's just the FryShake has different activities, order fry activity and order shake activity. And those are very similar to the other ones. In fact, they look about exactly the same. So I'm seeing a lot of boilerplate here that I think I just need like an extension method to publish, but we'll get there. And then we'll just be able to come in here and say publish order fry, publish order shake, and not have to create the activities. So that would be significantly nicer, in my opinion. And then when it's completed, we call get request, and then we call init. But I don't know why we get the request. Oh, because we want to get the size and flavor of the shake. And to do that, we do that. Great, awesome. Yeah, cool. Okay, so the fry completed, the shake completed, we get the order and we set the thing, set the description. If we do have a fault, we generate a regular fault using the regular fault with like faulted ID. So again, probably make some easier mappings for that, but right now that's where we're at. Yeah, so that's our type. That's where we're passing the information in. And that's our FryShake. And remember, our FryShake is where we order one item, but we actually get two items combined into one little box. It could be a Happy Meal for all I care. It doesn't matter. It's like I need these three items to make this one order line item show up. So that's I think a lot better than what we had in the past. I mean, this is significantly cleaner using the single state machine under the covers. I don't have to know anything about it. If you look at my DB context, it just has one type in it. The map is a little complex because we have a lot of JSON properties in it, but that's okay. That's an EF core thing. I do want to take a look at the future state though, because I feel like that's worth looking at now because that's changed a lot. So the future state, which is the single Saga that we're keeping around, has things like you would expect in a state machine. A current state, we have a timestamp when it was created, and we also have all of the terminal timestamps, such as completed, canceled, and faulted. Cancellation is not there yet, but it will be. And then deadline is just a concept that we pulled over from the earlier episodes where it's like, the deadline for this future is this timestamp. If we get to there at some point, I need you to either fault or do something. And I think as we get to eventing around futures, we'll figure that out because, hey, a future is a state machine. It can still produce events, and business events are very valid. So we'll definitely get to how as futures complete, we can produce events in addition to directed events for those responses. Yeah, so good times. Future message is a wrapper, which essentially allows us to store a dictionary of string object in the database such that we can deserialize it to a particular message type. I think I'm going to thicken this up a little bit and make it actually keep the message types that were from the incoming message headers so that I know the deserializable types that I can get, so I can do some scanning and do some kind of smart access to the cache of previously saved messages. So yeah, so I'll definitely get there, but right now I'm just saying to object, and if it doesn't work, hey, it doesn't work. Deserializer is kind of cruel that way. I use a hash set to keep track of the pending GUIDs. So every request I send out, every routing slip I run, all of those things that are going to come back have a GUID tied to them. And then I have results and faults. And I'm still newing these up, but I think I'm going to leave them empty. There's, like subscriptions, I don't new it up, so it's technically null until I add a subscription. Again, I'm just trying to see what makes sense as far as creating so that we don't get empty things in the database. Because if I go out to, what's it called? Data grip? Where's that thing? If I go out here and look, I can see I have several like empties, which I think a null would be a more efficient to keep track of. So, this is what the database looks like on that single state table. And I have a lot of these little empty arrays or empty maps that if those were null, I think that they would just not even allocate space for the column. So I don't know what's better. I'm not a database expert by any stretch, but that's something to think about. The subscriptions, like I said, are now kept within the routing, within the future state. And future subscription has an equality comparer so that if you add the same one twice, it doesn't add it twice. I think that works. I definitely found a bug in it, whereas if I put one without an address, it blows everything up. So it does check to make sure that there's actually an address, because you need an address, but you don't necessarily need a request ID. So that was kind of a thing. I do put the version property in here, so I support iSaga version. So if you use a repository that uses an incrementing integer, it'll still work. And I put a bunch of methods on this, which I know I don't like methods on state, but I didn't want a bunch of extension methods. So these might still end up being extension methods at some point, but right now they're on the instance. And I have things like add subscription, get request, try get the result, which will actually see if the result is present by ID in the results collection, and then use toObject to deserialize it to the type that you want. Try get fault does the same thing. Set result, that's one of our ones that actually goes in and says, okay, well, I have a result. If I have pending values, I might want to remove one, or I have a pending count. And if the pending count is 0 and false is 0, I will complete. Otherwise, if false is empty, I will complete. Once all that is done, I'll actually create the message and store it inside the, I'll call your message factory. And the reason I do that is because you might actually initialize your message with that completed timestamp. So if you're actually creating the completed message, it would be nice to have the actual completed timestamp. Same thing with set fault. It's just going against a different collection. Not everything adds to pending. So like request and response and routing slip don't add to pending, because technically they don't need to. They're a one-to-one. So there's no need to add them to pending, because as soon as they complete, they're going to complete. So that's why I'm saying pending should probably not be initialized to an empty set, so that I don't have to allocate the field in the database. Location is interesting, and this was a late addition. I wanted to be able to, since it's all in a single table, I wanted some way to be able to discriminate between the different types of futures, and I think this is going to be a good idea. I wanted to base 32 encode the GUID so it's smaller. And then I was like, do I even need the GUID? Because I have the correlation ID, which is exactly the same as the GUID. So I'm still thinking about this. but I want like the short name of the endpoint for that. So if I actually go out to DG and look at the location, I haven't run any of them. So let's see if I run this now, because again, I still have my API project running. Well, my API project is still in there. So if I run that and come into, I don't need this right now, but if I go into here, and let's just say I want to create a simple fry and a shake, a quick one, it turns around quickly. We can see in the log all of these things are running. Should come back pretty quick. Okay, so there's my fry and the shake. Same thing, small fries, medium chocolate shake. Now if I go out to the database and do a refresh, I should see a 47th line in here. I don't know, this thing's weird. Like sometimes it does what I want it to do and sometimes it doesn't. Okay, 47, 49. That's a fry future. Yeah, I don't know. This thing like sometimes gets it, sometimes doesn't. I don't know how it orders. Anyway, some of these have futures where you can see the ID is in there and it's just the GUID. There's a shake future, there's an order future, there's a fry future. So those three things got ordered for my FryShake. I don't know what the ordering is on this. This is really kind of weird. What should I do? Order by created descending. Yeah, so now they're at the top and I can see shake, fry, order. Okay. I do know a little bit of SQL left. That's awesome. Got a little bit. Okay. So yeah, so that's kind of where it's at. I do think I can do some grooming on this stuff, but again, I don't know. Am I over optimizing just to be silly, or is the information useful? I don't know. Kind of makes me concerned, but yeah, all of these are in the single database now, or a single database table. They all seem to not fight each other too much, which is great. I mean, you have row level locking in SQL, so it shouldn't fight each other. Yeah, I like it. I mean, I think it's going to be pretty cool. It's definitely cleaned up. I mean, if we look at the fry future or just any of the futures, fry future, onion rings future, I mean, that's a lot simpler in my mind. I mean, it's just so much cleaner. So again, that I think it's a major shift from what the mayhem we saw Friday night. So definitely drop some feedback because all this is in a single assembly now. If you want to test this out in your own projects, I had some people asking questions about it yesterday, so I was kind of like, wow, people are already kind of digging into this stuff. But the fork joint components project has everything you need. That's the base types. If you are going to use EF Core for your storage, you'll need some of the custom serializer value type things that are in here. I think it's under components. The JSON helper and the JSON value converter, you'll need those to use within your Saga map, because without those, the ones that are currently in the MassTransit library don't support interfaces. That'll be fixed in 7.1.3. I'll just move this over. It should have been there in the first place, but it wasn't. Yeah, but I'm digging it. I like it. I think it's pretty cool. So let me know what you think. Yeah, hit us up on Discord. If you're watching this on YouTube, leave a comment. If you're watching live, great. Thanks for joining us today. I know it's a Sunday and it's early, but hey, it was too cold to go riding this morning, so I came back home and decided to do this instead. Yeah, so I think it's going to go where upcoming episodes, like I said, we're going to include some content on. I want to get cancellations and timing in here at some point. I definitely want to cover events around durable futures. I want to look at how we can do retries and fault handling. And I want to see how we could actually get a durable cache to be, or I'm sorry, a durable future to be a way of caching remote data for us. So, I think that's going to be a pretty useful one, is to be able to say, okay, well, use the deadline to basically say that this future expires at this time, or maybe there's an expiration concept in here, to where we can sweep out those old futures, and when we ask for them again, it creates a new one. So definitely some ideas thinking around of how these can be composed into some harder problems that I've tried to solve, specifically around caching backing service data to reduce the load on them. And then also to just kind of obscure the retry and fault handling of a request response service behind some sort of thing. So So yeah, I like it. It's definitely feeling good. So leave your comments. Thanks for joining. Next episode will be coming out when it's ready. But in the meantime, have a good day, and we'll catch you on the next one.